Hello! In this video, we will demonstrate how to control a Yaskawa servo motor from LabVIEW using Mechatrolink, beginning from scratch. Introduction: what you need to get started. This is the equipment you will need to get started. First, you'll need a computer with a PCI slot, the XP or Vista operating system,
and LabVIEW 8.5 or 8.6.
You'll also need the Mechatrolink COM card, the NT110, a servo amplifier, and a servo motor, a motor power cable, a motor encoder cable, Mechatrolink communications cable, and 2 Mechatrolink terminators. Section 1. How to install the PCI COM card. Put the card in a free PCI slot. Section 2. Download and install the Mechatrolink driver.
You'll need to obtain the driver package from National Instruments or Yaskawa's websites.
If you get any pop-ups regarding a detection of new hardware, just cancel that for now. After you've extracted it, open the folder and run the setup file. Click Next to accept the default installation path. If you accept the license agreement, choose the I accept option and click Next. Click Next again, and the driver will begin installing.
You should now see a message showing the location for the hardware driver for the NT110 PCI COM card. Please make note of it. You will need it to complete the installation.
Go to your device manager and initiate the Found New Hardware wizard. Select the option so you can choose the driver to install. Choose to install from a specific location. And browse to the location where the driver was installed. Click OK. Next.
In some cases, Windows may set a restore point and will back up your files. Go to the location you noted earlier to find the NT hardware driver.
The driver will now install. Click Finish and the new hardware will be installed. Section 3. Connecting your servo. Put the motor power cable into the servo motor. Put the motor encoder cable into the servo motor. Put the motor power cable into the amplifier and screw down the ground wire. Connect the motor encoder cable to the amplifier and wire the input power into the amplifier. Then screw down the input power's ground onto the amplifier. Connect a Mechatrolink terminator into the communications port of the amplifier and connect a Mechatrolink network cable to the other port. Connect the other end of the Mechatrolink network cable to the PCI network card and a Mechatrolink terminator to the other port. Turn on the power going into the amplifier. You will see the front panel light up with the status of the amplifier, which we will address in the next section. Section 4. Setting up the servo. Start the Setup utility. Click the Detect Nodes button. The utility will search for Mechatrolink devices. Once found, any alarm status will appear in the Alarm Data tab.
We notice that there is no alarm, but there are 3 status bits that are illuminated: the negative over travel, the positive over travel, and main power on. The status of these indicators means that the overtravels have not been wired in. For the purpose of this demonstration, we will disable these by going to the Drive Parameters tab. We read all parameters, which will populate the data fields for the servo drive. Let's look at 50A, negative overtravel, and 50B, positive overtravel. To disable overtravels, we click on the 50A data cell and change it to 8881. The cell changes to red, indicating that the data has been changed, but has not been saved yet. Next, we select the 50B data cell and change it to 8888. Now we can write the modified parameters to the drive. When we go back and click Read, we see that the changes have been saved to the drive. Another way we could have made these changes is by calling up each parameter by its data tag in this area, but we chose instead to make changes in the drive's data field section. When we go back to the alarm status table, we notice that the changes have not fully taken place yet because the servonet has not been reset. Click on Servonet Reset and the changes are finalized, and we have disabled both the positive and negative overtravels. The next parameter we will examine is PN002. The setting of 0000 is the software's default setting, which indicates that the drive is configured to work with an absolute encoder. Since we are using an incremental encoder on our servo motor, we need to change this to 0100 by following the same procedures as earlier shown to change and to save this setup. All the needed changes have been configured. We have set up our drive by disabling the positive and negative overtravels, and we have changed the default from absolute to incremental encoder feedback. We are now ready to go to the Tuning tab. The Sigma Phi servo has two methods of operation, auto-tuning and manual. Sigma 5 is unique in that its real-time adaptive tuning will work for the majority of applications with no additional manual adjustments required. Let's look at the auto-tuning tabs. Your first choice is to have tune less, on or off. Let's choose on. The next tab shows you can operate the Sigma 5 in velocity or position modes. Let's choose positioning. Flip the switch to servo on. This will enable the servo. Examine the motion settings and click Start Move. Each time you click Start Move, the servo motor will spin. Change the direction of the servo motor by choosing Reverse. Now, when you click Start Move, the servo motor will spin in the opposite direction. Congratulations! You have just used the Mechatrolink driver utility to set up your servo. Now you're ready to start with your mechatronic application using LabVIEW to create and control it.